today's lesson is on integrating using miscellaneous substitutions. So some substitutions that are a little bit different than what typically we see. Typically when we're doing a substitution, you see the function and its derivative there, but there's some other cases that we can use substitutions to make things simple. Now these are tricky because you're looking at all these things and they all kind of look the same, but they're kind of different. So it's okay to do a substitution and then maybe you didn't make the right substitution. So go back and try again. All right, this first one. In the denominator, I just have a single thing. So I can split this up as the integral of x over, and I'm going to rewrite the square root as x to the 1/2. And you can keep this in the same integral. I'm just splitting it up. To make it clear we're doing two different things. So here, this is going to be x divided by x to the 1/2. This would be 1 minus 1/2, which is just going to be x to the 1/2, or the square root of x. I left the radical here because I'm going to make this a 2, makes this a 1/2. So this is going to be 1/2 times 4 square root of x. Now I'll do this integral and add that along. So this is going to be 2/3 x to the 3/2 using the power rule. This will be plus 2 root x, or x to the 1/2, plus c. A lot of these substitutions deal with radicals because there's kind of an interesting thing that can happen when we do a u substitution with the square root of x. When we do du, we get 1 over 2 root x dx. Now here, this is going to get replaced with u, but I don't have this in the problem. But that's okay, because u is really, or the square root of x we just said is u. So this is really 1 over 2 u dx. So I'm going to put that on this side. So I'm going to replace dx with 2u du, and that will actually make our problem easier. So we're going to have the integral. Dx is going to get replaced with 2u du. I'm going to come back to this, and I'm replacing the square root of x with u. Okay, but we still have an x, so I needed to go back to this. If u equals the square root of x, then x is going to equal u squared. So we're going to have 4 plus x squared u. Well, if you see, I have a u in the numerator and a u in the denominator. Sorry, this is u squared. U squared. So those u's go away. So now my integral is 2 over 4 plus u squared. Well, hidden in this, oddly enough, is tangent inverse. So this is going to be 2 times 1/2 tangent inverse u over 2. So this is going to be the tangent inverse. U was the square root of x over 2. Alright, so this next one, again, we have this pesky radical that we'll get rid of by making a substitution. So du is 1 over 2 root x dx, and I'm going to do the same thing. This is going to get replaced with u, and I'm going to multiply it over. Okay, so that's going to take care of that and that. For u, or for the x here, x is going to equal u squared again. So I'm going to have the integral. Square root of x gets replaced with u. X gets replaced with u squared. And dx gets replaced with 2u du. So this is going to be the integral of 2u squared over u squared plus 4 du. Now, it may be tempting to cancel out those u squareds, but that does not work because of this 4. Anytime you have a quotient and the degree is the same or higher in the numerator, if this was a degree 3, then what we're going to do is use long division to simplify this fraction and to split it up. So we're going to take u squared plus 4. We're literally doing this division. We're taking 2u divided by that. So what number would you multiply u squared by to get 2? That's going to be 2. So multiply down. We get 2u squared plus 8. And we're subtracting that. So 0 minus 8 is a negative 8, which means we have a remainder. So this is going to be minus 8 over u squared plus 4. So I'm changing this integral. I'm just changing what this looks like. So this is now going to be the integral of 2 minus 8 over u squared plus 4. Okay, now we can do this integral because I can integrate this and I can integrate this. So the integral of u is going to be 2u minus 8 times, this again is tangent inverse, so 1/2 tangent inverse u over 2. Then we'll go back and do our substitution with the square root of x. So we have 2 root x minus 4 tangent inverse root x over 2 plus c. For number 4, I'm going to rewrite the radical as just x to the 1/2. And we don't have to do a u substitution here because I can simply just multiply this in. So we're going to have x to the 1/2 times x to the 1 is going to be x to the 3/2 plus 4x to the 1/2. So we're going to add 1 to this power, so that's going to be 5/2. So we'll divide by that, or multiply by the reciprocal. Add 1 and divide by the reciprocal there. So this is 2/5 x to the 5/2 plus 8/3 x to the 3/2 plus c. I can do that with a polynomial. I cannot do that with a radical, though. I can't just multiply that in. But we know we can get rid of the radical if we let u equal square root of x. So du is 1 over 2 root x plus 4, which is u. So multiply that over. So 2u du equals dx. That gets rid of this. That replaces that. X, however, I have to deal with. So u squared is going to equal x plus 4. So x is going to equal u squared minus 4. So x gets replaced with u squared minus 4. The square root of x plus 4 is now u, and dx is 2u du. Which actually made this simpler to do because now I can combine things. So this is u squared minus 4 times 2u squared. And I can multiply that through. So this is going to be 2u to the 4th minus 8u squared. And we're going to add 1 to the exponent and divide. So we're going to have 2/5 u to the 5th minus 8/3 u cubed plus c, and then we'll replace back in our root x plus 4. Next we have a definite integral. I'm going to again let u equal the square root of x. This one's a definite integral, so I'm going to change the bounds. Square root of 16 is 4. Square root of 9 is 3. Du is going to be 1 over 2 root x. And again, I'm going to multiply that right over. So 2u du equals dx. That's that. That's that. This x is going to equal u squared. Now again, you may pick a u and it makes it simpler and great. You may pick a u and it didn't help you. So be flexible on these. They take a little practice. Dx is 2u to u. X is u squared. Square root of x is u. Well, I have a u in all three of these, so I can divide that out. So we'll have 2 du over u plus 1. Okay, so that's going to be a natural log. So this is going to be 2 natural log u plus 1. This one we're evaluating from 4 to 3, so I don't have to replace back in because we dealt with that from the beginning. So this is going to be 2 ln 4 plus 1 is 5, plus 2 ln 3 plus 1 is 4. And I don't need the absolute value because those are positive numbers. Okay, so we've got some more examples here. Again, this is kind of tricky because these two look almost identical. It's just we've got an x squared on the inside, an x squared on the outside. Here the x squared's on the outside, not on the inside. Here, this is going to be a u substitution with what's under the radical, because I know the derivative of x squared is 2x, and I have an x here. So if I let u equal x squared plus 1, then du is going to equal 2x dx. So this will be 2, so we'll have a 1/2. So 2x dx is just a u, so this is just the square root of u du. So this is going to be 1/2 times 2/3 u to the 3/2. So this is going to be 1/3 instead of u, x squared plus 1 to the 3/2. For this one though, if I take this, it's not going to make our lives any simpler. And again, you might try it and then end up with something that's ugly. Here, I'm going to make my u equal that whole square root again. And there's not always just one right way to do these. You may end up doing a different u substitution that works for you as well. So we'll multiply that over. 2u du equals dx. Okay, so that deals with this, that deals with this. We have an x squared here. So I'm going to solve this. So x is going to equal u squared minus 1. So let's see where that gets us. So x is going to get replaced with u squared minus 1. So that's my x squared is now u squared minus 1 squared. The square root of x is u. My dx is 2u du. Okay, so did that make our life simpler? Yes, it actually did. We're going to do some work before we get to the integral. I'm going to FOIL this out. So this is going to be u to the 4th minus 2u squared plus 1 times 2u squared du. Now I'll distribute that in. 2u to the 6th minus 4u to the 4th plus 2u squared. Now we can integrate. We just have a nice polynomial here. So this is going to be 2/7 u to the 7 minus 4/5 u to the 5th plus 2/3 u cubed plus c. And then we'll plug back in our u. All right. So again, if these had been switched, then we would just do a u substitution with just what's under the radical. But since this is not the derivative, we'll go ahead and let u equal our 16 minus x squared. And again, just kind of see where this leads us. Du is going to be 1 over 2 root 16 minus x squared times a negative 2x. All right, so I'm going to move, well, the 2's cancel. So I'm going to multiply, this is u, so we're going to have u du is equal to, so we multiplied that over, I'm left with a negative x dx. Okay, so I can get an x out of this, but that still leaves me with an x squared. This, if I say u squared equals 16 minus x squared, that means x squared is going to be 16 minus u squared. So let's rewrite this. I'm going to put a negative out here because I'm going to split this up into a negative x and an x squared. Okay, and we're going to make all our u replacements here. So the negative goes along for the ride. Negative x dx gets replaced with a u du. So I'm going to put the u there, I'll put the du in the end. X squared gets replaced with 16 minus u squared. The square root of x minus x squared is u. U. So again, what did this get us? Multiply the u and the u. So we have a negative u squared times 16 minus u squared. Distribute that in. Now we integrate. So this is going to be a negative 16 over 3 u cubed plus, if I distribute the negative through, u 1/5 u to the 5th, and then substitute back in our u. So negative 16 thirds square root 16 minus x squared cubed 1/5 All right, and again, these are tricky, but here I know that the square root of, or the derivative of square root of x is 1 over 2 root x. So I have that derivative here. So I'm going to go ahead and let u equal the square root of x. So du is 1 over 2 root x, which in this case I'm not going to multiply that over because I need to replace that. So I'll make that a 2, which is really the same as a 1/2. So I'll also multiply by 2. So this is going to be 2 times the integral. Now we have sine u, and then 1 over 2 root x dx is du. So this is a good old-fashioned integral of sine is a negative cosine u. So this guy is negative 2 cosine square root of x plus c. This last one, we don't have this derivative. So as we have done many times, let's just go ahead and let u equal square root of x and see where that leads us. So since this isn't a part of our integral, we'll go ahead and multiply that over. So now we have the integral of 2u times the sine of u du. So this did make our lives a little easier, but we are going to have to do an integration by parts. And we know that because we have a product here. So I'll go ahead and do my, and it's a little confusing because u, but we're good. So this is going to be 2u, derivative of that. Sine of u is going to be our dv. Integral of that is negative cosine. Integral of that is negative sine. So plus, minus, plus. All right, so we've done the integral here. So this is now going to be a negative 2u cosine u plus 2 sine of u plus the integral of 0 c. Then we can replace. So it's going to be negative 2, replace back our square root of x, cosine square root of x plus 2 sine square root of x plus c. So again, have some flexibility with this. You may end up going down the wrong road, and that's okay. Just understanding this trick with the square root will help you out a lot. But again, it just takes practice.